Hi, in today's video, we are going to look at 3 examples of solving systems of equations using the elimination method. So before we get started, the whole goal of the elimination method is to take a system that has 2 equations and 2 different variables, right? Currently we have a top and a bottom equation, so 2 of those, and then we also have x's and y's, 2 different variables. Our goal is to take 2 and 2 and eliminate it down to just having one equation with one variable, which we've been solving for many years at this point. So again, our whole goal is to end up eliminating a variable and an equation so we get something much simpler to work with. So looking at our first example, the very first question says, are both of our equations in standard form? So standard form is where x's and y's are on one side and the constant is on the other side. Our x's are aligned, our y's are aligned, and they equal the constant on the other side. So yes, indeed. So the next question says, look at our equation. So go ahead and copy them back down. All right, so we're looking at the equations and we are asking, are there any opposite variables? And there's some examples given down here. So it says examples of opposite variables would be like a positive 3x and a negative 3x, or a positive y and a negative y. So inspecting what we have a 3x and a negative 3x. So yes, we do have opposite variables. We're going to continue down the yes pathway once again. Now, step 3 says, add the 2 equations together. And this is when the elimination should happen because it says we're doing this to make a new equation with only one variable. So go ahead and copy them back down. So we have 3x plus 6y equals 18. And negative 3x plus 2y equals 14. And we are going to be adding these equations together. So when we do this, 3x plus negative 3x, that's a 0 pair. I mean, we could write 0x, but we don't need to. And then we have 6y plus 2y, which gives us 8y. And then 18 plus 14 gives us equals 32. So we started with 2 equations, which had an x and a y, so 2 variables. And after adding together our equations, now we just have this one single equation with only one variable, and we should be able to solve this in one step. So going to step 4, it says solve that equation to find the value of our first variable. So if we have 8y equals 32, we should know that we can divide both sides by 8. And that tells us that y equals 4. So we have found y, we still need x. Going to step 5, we are going to substitute the value for the variable we just found, so that y equals 4, into one of the original equations, and then we'll solve for a remaining variable. So I'm going to go back to the top. We have 2 original equations. It truly does not matter which one that you pick. It is totally personal preference. For whatever reason, this top equation is calling to me. If you would rather use the bottom one, you do you. Truly does not matter. But make sure that you are choosing from up here at the beginning of your problem in those original equations. So I am going to choose the first one just because, again, no rhyme or reason. So we have 3x plus 6y equals 18. But we have found that y is 4, so I'm going to rewrite this as 3x plus 6 times 4 equals 18, which is the same thing as saying 3x plus 24 equals 18. And then you can subtract 24 from both sides, which tells us that 3x equals to negative 6. And that x, if you divide both sides by 3, equals negative 2. All right, so zooming out on our work, we had opposite variables ready to go. So we were able to add our equations together, which eliminated the x, and it gave us one single equation with one variable, which we were able to figure out y was 4. And then we picked our favorite equation from the original system, and we substituted 4 in for y, which allowed us to find x was -2. Now we did do a decent amount of work, so it's possible that we could have made mistakes. So step 6 is where we're going to next, and it says check the solution by substituting the values for the variables we found back into both original equations. So our first equation is 3x plus 6y equals 18. And our second equation is -3x plus 2y equals 14. So when we substitute our values for x and y in, what we're looking for are true statements, because the definition of a solution to an equation is a value, or in this case, an ordered pair of values that makes our equation true. So instead of x, we are going to substitute -2. And instead of y, we are going to substitute 4. And we're just fact checking, does this really equal 18? So depending on your teacher's expectations, you could just type this whole piece into your calculator and see if it equals 18. Or we can do it in our head a little bit. This is -6. This is 24. 24 take away 6 is 18. Which does in fact equal 18 like we hope it would. So I'd say this side checks out. And then of course, if you were to just type this entire expression into your calculator and click enter, it would equal 18. Checking the second equation, because sometimes the first one works, but we made an oopsies and then it doesn't work out for the second one. We are going to do the same process of substituting in -2 for x, and then substituting 4 for y, and then we are just fact checking, does it really equal 14 like it's supposed to? So if we were to do this ourselves, negative times a negative would make a +6, plus 8 more, 6 plus 8 is 14. So I'd say that's a true statement, that checks out, right? 14 does equal 14. And then again, if your teacher is okay with it, you could absolutely just type this whole thing into your calculator, click enter, and confirm that it did make 14. So for our solution, we did find y first, but just be cautious of remembering that it always goes x, then y, always in ABC alphabetical order. So our final answer is going to be -2 for x, comma, 4 for y. And so if we were to graph the systems of equations, this point would be the point of intersection of the two lines. All right, moving on to example 2. I'm going to zoom in on our problem. So we have a brand new system. Again, it starts with 2 equations and 2 variables, and our goal is to use this elimination method to turn this into one equation with one variable by, again, eliminating one of each. So our first question says, look at the equations. Are they both in standard form? Which again means x's and y's are on one side, and then it equals the constant, which is the plain number, on the other side. This first equation is good to go. It goes x's, y's equals constant. The second equation is not in the right format, so we are going to need to go down the no pathway and do a little bit of scratch work. So that brings us to this box. It says rewrite the equations into standard form, which really, again, is just saying get the x's and y's on one side and get the constants on the other side. So looking at what we got, the first one was good to go. The second one is what we needed to improve. So I'm going to copy down that second equation, which was y equals 2x plus 5. And we need to get our x over. So we're going to say minus 2x from both sides, which gives us the 2 x's we just subtracted plus the y that was already there equals 5. Now you are so welcome to take fewer steps if this is something that you are comfortable rearranging, right? I showed all my work by doing this. do what you're comfortable with, and of course, make sure you're following your teacher's expectations. But now that we've rearranged, we are going to move over to step 2, which says look at our equations. So the first one was good, so I'm just going to copy down 3x plus 4y equals 9 again. And then our second equation is what we had to rearrange. So that was this one over here, which now is good to go. So we have negative 2x plus y equals 5. And the question is, are there any opposite variables? So again, that would be like a positive 3x and a negative 3x, or a positive y and a negative y. So for our x's, we have positive 3 and negative 2. So nope. And then for our y's, we have positive 4 and then positive 1. Also a nope. So we are going down the no pathway. All right, so this brings us to this box, which says we are going to multiply one or both equations by a non-zero number to create a pair of opposite variables. So go ahead and copy down what we're working with again. All right. So our goal is to make a pair of opposite variables, and it doesn't really matter if it's in the x's or if it's in the y's. So we're trying to do this with the least amount of effort possible. To make 3 and 2 match, I would have to think about their least common multiple. So if I'm counting up by 3's, I'd have 3, 6, 9, 12, etc. And then to count up by 2's, I'd have 2, 4, 6, 8, so on, so on. I found that 6 is a match. In order to make the x's both be 6, I would have to multiply both the top and the bottom of the equation, which is 2 steps. So I want to see if I can get away with less work by doing the y's. So for the y's, we have 4 and then a 1. If I count up by 4's, I'd have 4, 8, 12, so on, so on. And then if I count by 1's, 1, 2, 3, 4, 4 is actually the least common multiple for the y's. I am very much pro, let's get rid of the y's this time. Let's eliminate those, because the top equation already has a 4, which means I wouldn't have to do any multiplication up there. And the bottom equation just needs to become the opposite of that, so I can do that in one multiplication. Now, while technically it's a-okay to target either variable to eliminate, again, I am going to choose the y's because I can do it with the least amount of effort. So what I'm going to do is multiply everything by negative 4. The reason for that, up top I have positive 4. To eliminate that, I would need negative 4 on the bottom, and right now we really have a positive 1 here. So go ahead and we are going to multiply the entire bottom equation by negative 4. Just make sure you don't forget any of the terms. While we're doing that though, just remember we're not making any changes to the top. We chose to do this in a way that we would only have to do one multiplication. So the top equation is still just chilling at 3x plus 4y equals 9. And then multiplying every single term of the bottom equation by negative 4, well, negative 4 times negative 2x will give us positive 8x. Negative 4 times 1y gives us negative 4y. And then don't forget about the constant on the other side. Negative 4 times 5 equals negative 20. All right, so the entire purpose of doing this is so we end up with opposite variables. We did not have them to begin with, but we should now. So we are ready to move along to step 3, which says add the 2 equations together. And again, if we did this right, we should go from having 2 equations with 2 variables, eliminating that down to only have 1 equation with 1 variable. So we are going to take our new and improved system and copy that down over here. So 3x plus 4y equals 9. And then the equation that I multiplied by -4 became 8x. Take away 4y equals -20. And again, if we do this correctly, we should end up with one equation with one variable. All right. So going and adding these together, 3x plus 8x gives us 11x. Positive 4y plus -4y. Well, that's a zero pair, so I could say 0y, but I'm just not going to write it. They're gone. Eliminated. And then for our constants, 9 plus -20, that's the same thing as 9 take away 20. That equals -11. And I like this a lot more because up here we had two equations with two variables. And now I have one equation with one variable, which should be able to be solved in like one step. So going to step 4, it says solve that equation to find the value of our first variable. So we have 11x equals -11. And again, I told you can do this in one step. So dividing both sides by 11 gives us x equals -1. So we found one of our two variables. To find our second variable, we are going to move on to step 5, which says substitute the value for the variable we just found into one of the original equations, and we will then solve for our remaining variable. So I'm going to go back to the top. And again, it is totally our choice, whichever equation we pick, but it does need to come from the originals, right? They gave it to us, so we know that 0 mistakes could happen at that point. We have done a lot of rearranging, right? Here we had to shuffle things around. In this step, we had to multiply things. So make sure that you're always going back to the original equations. This time, I prefer the bottom equation. It is totally up to you which one that you want to pick. I think the bottom one will be easiest if our goal is to find y, but if you liked the top one better, you do you. It does not matter. So I'm going to copy down the original equation y equals 2x plus 5. And then I am going to substitute in the value that we just found, which is that x equals -1. So this tells me that y should be 3, right? Because this would be -2 plus 5, which is 3. You could also totally type this into your calculator. You'll still get 3. So taking a little zoom outwards, we have done a heck of a lot of work on this problem, which means it is possible that we made a baby mistake somewhere. So I think our answer is -1 for x, 3 for y, but we are going to check our work to be confident. So step 6 says, check our solutions by substituting the values for the variables we found back into both original equations. So go ahead and copy down both of the originals. So our first one is 3x plus 4y equals 9. And then our second one is y equals 2x plus 5. All right, so we are going to substitute what we think is the correct set of answers. So -1 for x, 3 for y, and just make sure that when we substitute this, it produces a true statement. So I'm substituting -1 for x, and then for y, we are substituting in 3. And then I'm going to double check, well, does that actually make 9? So you are absolutely welcome, if your teacher is okay with it, to just type this entire expression into your calculator and see what plops out. So if I were to do 3 times -1 plus 4 times 3, and I click enter, I get 9. But if your teacher wants you to try and reason this out on your own, I would know that this is -3 and this is 12. -3 plus 12 is the same thing as 12 take away 3, so that gives me 9. And 9 does in fact equal 9, so that is a true statement, and that equation checks out. Going to our second equation, we're going to substitute 3 for y, -1 for x, And we're just double checking, does this really work out? So 3 is obviously 3. And then again, if your teacher's all right with it, type this into your calculator, see what plops out, hopefully 3. But we can do it in our head. 2 times -1 is -2 plus +5 equals 3. And 3 does in fact equal 3. So that is another true statement. So this tells us that 100% without a shadow of a doubt, we did a perfect job solving this system of equations. And the final step is to just make sure that we format our answer correctly. So we have x before y, which gives us -1 and then 3. All right, zooming out to admire our work, that was a long problem. All right, moving on to our third and final example. Here is our system and assessing to see if both equations are in standard form. The top one is x's and y's are together on one side, the constant is on the other, but the second equation, not in standard form. So we need to go down the no-go side once again. Nope, they are not both in standard form. And so we are going down to the scratch work side, which says rewrite the equations, or in our case, it's really only the bottom one that needs to be rewritten. And we are going to make sure that they are in standard form with the x's and y's on one side and the constant on the other side. So the first equation is already fine. We don't need to bother with that. But we will deal with that second equation, 2y equals 5x plus 11. So I need to get the x's over to where the y is, so I am going to subtract them on both sides. And then if you want to show your work extra nice, you could even have your 5x kind of over there on the side to show that separate term from the 2y's, like they're not like terms. So when you do this, this ends up giving us -5x plus the 2y's that were already there equals 11. All right, so we did that bit of scratch work and we are ready to follow our arrow this way, which is step 2. Look at the equations and see if there's any opposite variables. So I'm going to copy down the first equation that didn't have any problems. Right, so that was this one right here. And then I'm going to copy down our new and improved second equation from over here that is now in standard form. And now it gets a smiley face because it's in the right order. And we're just checking, are there any opposite variables? So we have +2x, -5y. Oops. +2x and -5x. Not opposites. And then we have +7y and +2y, definitely not opposites, right? They're not even opposite signs. So once again, down the no path. And we need to figure out how to multiply either one or both equations so we can actually create these opposite variables. So go ahead and copy down what we got again. So 2x plus 7y equals -20. And then -5x plus 2y equals 11. So I'm going to kind of talk through what our options are just to see if one variable or another could end up saving us a little bit of effort. But again, it doesn't really matter if we're choosing to eliminate the x's or the y's. So I always try and go for the one that would save me effort if that's possible. So to make the x's get eliminated, I would need the 2 and the 5 to match up. So thinking about what the least common multiple of 2 and 5 would be, if you count up by 2's, you'd have 2, 4, 6, 8, 10, 12, and so on. Counting by 5's, you'd have 5, 10, 15, 20, and so on. The least common multiple that I rattled off was 10. So to make that happen, 2 would have to get times by 5, and then 5 would have to get multiplied by 2. So that would be 2 multiplications to make that happen. Checking in on the y's, to figure out where 7 and 2 would match up, counting by sevens, I would have 7, 14, 21. And then counting by twos, 2, 4, 6, 8, 10, 12, 14. Finally, I get a match. So in order for this to happen, I would have to multiply the 7 by 2 and then the 2 by 7. That would make them both positive 14. On top of that, we would need to throw a negative in somewhere. I don't really think one variable is going to be a lot easier than the other. So I'm going to choose the x's just because they're up front, and then one's already positive, one's already negative. No matter which variable we choose, it would require 2 multiplications this time to get them to match up. So going to this top equation, to make 2 turn into 10, which was the least common multiple of 2 and 5, I would need to multiply this equation by 5. And then to make the bottom equation into 10, I would need to multiply 5 by 2. And then I love that I already have one that'll be positive, one that will be negative. That way everything is totally opposites. Just make sure, please, that you are going to end up multiplying these numbers to all 3 parts of each equation. Right? The biggest mistake that I see is people will do a lovely job multiplying to the x's and the y's, and then the constants, they get left out. People forget about them. All right, so let's go ahead and start doing these multiplications. Our first one is 5 times 2x, which is 10x. Now we'll have 5 times 7y. That's positive 35y. And then 5 times negative 20 is negative 100. Doing the second equation, 2 times negative 5x gives us negative 10x. And then 2 times 2y gives us positive 4y. Make sure you always have a plus or a minus to separate your terms. And then last but not least, don't forget this one as well. 2 getting multiplied to the 11 equals 22. So assessing what we've done here, I do see that I have a pair of opposite variables at this point, which is exactly what we wanted, right? The whole point of doing this multiplication process was to create a pair of opposite variables in one of these terms, right? It could have been the x's, could have been the y's. Now that we've got it, we're good to go. We are going to finally move on to step 3, which is adding these equations together. And this is where that elimination magic happens. Now that we have opposite variables, when you add your equations together, we're going to say goodbye to having 2 equations and 2 variables, and we will say hello to only having 1 equation with 1 variable, right? We've eliminated a lot, and now we'll have a very simple equation left over. So go ahead and copy all of our new and improved system down. So you've got to zoom out a little bit. 10x plus 35y equals negative 100. And then negative 10x plus 4y equals 22. And we'll go ahead and add these together. So our x's will get eliminated. This is a 0 pair. There's no need to write 0 x's. They're gone. We don't need to write it. And then 35y plus 4y gives us 39y. And then on the other side, negative 100 plus 22 gives us negative 78. Then stopping to assess what we've done, we have 2 equations with 2 variables, and then after adding, we eliminated the x's, and we just have 1 equation with 1 set of variables, which is lovely. So going to step 4, we're going to solve this 1-step equation to find the value of our first variable. So 39y equals negative 78. To solve this, we need to divide both sides by 39. And I'm going to use my calculator for this one, and I'm finding that y equals -2, or so I believe, right? There is a lot of potential for oopsies. We've done a lot of work here. We've rearranged, we've multiplied, we've had to add stuff together. There's plenty of room for oopsies, so that's why we'll check ourselves when we're done. But moving on to step 5 now, we're going to substitute the value of the variable we just found into one of the original equations and then solve for our remaining variable. Looking at our two equations, I don't have a super strong preference either way, but I think I'm going to choose the bottom equation just because, I don't know, 11 is smaller than dealing with a 20. But you can choose whichever you want. So I'm going to copy down that original second equation of 2y equals 5x plus 11. And then I'm going to substitute in -2 for y. So this gives me the equation -4 equals 5x plus 11, which is a two-step equation. So I'm going to subtract 11 from both sides, which gives me -15 equals 5x. And then to finish solving, I would divide both sides by 5, which gives me -3 for x. And again, or so I think. We need to check ourselves. So doing our final step, step 6, it says check the solution by substituting the values for our variables back into both original equations. So zooming out so we can see our originals to copy them down. Our first one is 2x plus 7y equals -20. And then our second original equation was 2y equals 5x plus 11. All right, so we will know that we have done a good job if when we substitute our values for x and y into both equations, we get true statements for each one. If we get something that is untrue, we would need to circle back and figure out where some mistakes have occurred. So looking at this first equation, instead of x, we're substituting -3, and instead of y, we're substituting -2, and we're just checking, like, does it really equal -20? So if your teacher is cool with it, go ahead and type this whole expression into your calculator and see what plops on out. But if they want you to work on doing it in your head, we got that too. So our first term would be -6. Our second term would be -14. When we add those together, -6 plus -14 equals -20. And then -20 equaling -20 is in fact a true statement, so this side checks out. And then doing our second equation, we're going to substitute -2 in, and we're just making sure that it'll equal the other side. Substituting -3 for x. All right, so our first side equals -4. And then over here, again, if you have the permission from your teacher, you could type all of this into your calculator. We're just going to do it ourselves. So 5 times -3 is -15. -15 plus +11 equals -4. And -4 does equal -4. That is a true statement. So looks like both of our answers for x and y checked out beautifully. Be cautious when you rate your final answer. So remember, x goes before y. While we did happen to find y first, y should always be the second coordinate. So it's going to be -3 for x, comma, -2 for y. All right, that was a lot of work. Hopefully you learned a lot in this video. This is how you solve systems of equations by the elimination method. Bye.